Alright, so we're going to look at mixture problems, taking two different substances or quantities of something and putting them together and seeing the result of that. And there's going to be two types. There's going to be one's based on like cost per unit and then one based on a percentage. So we're going to talk first about the stuff about the cost per unit. And the setup we're going to use is V equals AC, where V is the value of our purchase. Usually we're going to be talking about dollars. And A is the amount of the purchase. So how many pounds did we purchase of this, or ounces or kilograms or something. And then C is how much did we pay per unit. So how much does it cost per pound, per ounce, or whatever. Kind of a way to see how this all matches up with each other. Let's say I wanted to figure out, I purchased 3 t-shirts, they each cost $19.95. How much did I spend? So using this formula, what I'm looking for is the value of the purchase. How much money did I spend? A is how many did I buy? 3 t-shirts. And then C is how much did they cost per shirt? And they cost $19.95 each. So taking 3 times $19.95, I spent $59.85 before tax or whatever. So that's how this formula works. How many are you purchasing and how much does each unit of it cost? So value 1 plus value 2 equals the total value, how much you spent on the first one plus how much you spent on the second one, is going to tell you how much you spent all together with your mixture. How we calculate the values, we take how much we bought times how much each unit costs, how much we bought times how much each unit costs, and that gives us the total value. Though for most of these problems we're going to be looking at looking at the total average cost. Either we're going to be told it or we're going to try to find it. So in that case we're going to look at the total amount times the total average cost. One thing to note, the amount of the first one plus the amount of the second one equals the total amount. So you buy 5 pounds of the first thing, 10 pounds of the second thing, you have 15 pounds altogether. That makes sense. The total cost, though, is not found by adding the individual costs. Instead, it's a weighted average cost. It's somewhere in the middle, closer to the one you have more of. So how do we calculate that? Well, it's cost per unit, so we're going to take how much we spent altogether, which would be our total value, and we're going to divide it by how much material we have altogether, our total amount. Find the cost per pound of a coffee mixture made with 8 pounds of coffee that costs $9.20 per pound and 12 pounds of coffee that costs $5.50 per pound. So what we don't know is the total cost per pound of our mixture. We know we know that how much we spent on the first coffee plus how much we spent on the second coffee is going to give us our total amount we're going to spend. And the way we figure out how much we spent, we take how much we have of the first one times its cost per pound, how much of the second one times its cost per pound, and that's going to give us how much we have altogether times its cost per pound. Now we do know how much we have of the first one, 8 pounds. We know how much we have of the second one, 12 pounds. How much do we have altogether? Well, we have 8 plus 12, 20 pounds altogether. So we know everything but our C total, our total cost. And that's going to be our X. So we're going to fill in everything. 8 pounds at $9.20 per pound, 12 pounds at $5.50 per pound, 20 pounds at some number of pounds. So we're going to multiply the units on the left and combine like terms. So we spent $73.60 on the first one, $66 on the second one. Spent a total of $139.60 altogether. On 20 pounds, divide both sides by 20, our coefficient, and we get that we spent, or the items are going to cost, the coffee is going to cost $6.98 per pound. And you could look at, we have a little bit more of the $5.50 than we have of the 8, the $9.20, so our average is a little bit closer to $5.50 than it is $9.20. Alright, an herbalist has 30 ounces of herbs that cost $2 per ounce. How many ounces of herbs costing $1 per ounce should be mixed with these 30 ounces of herbs to produce a mixture costing $1.60 per ounce. So what are we looking for? How many ounces of the $1 herbs? All right, so go to our formula, V1 plus V2 equals the total value, and we're going to calculate each of the values here. Now, in order to do this, we need to know the total amount. We don't know the total amount directly. We do know we have 30 of the first type of herb, and we have X number of ounces of the second type of herb. So the total would be the total of 30 and X. So X plus 30 ounces. So we're going to fill that in for our total amount in our formula. So 30 of the first one, its costs per ounce, X number of ounces of the second one, and its cost per ounce, $1, and then our total number of ounces, X plus 30, and our overall total costs of our mixture. And now we're just going to work this equation out. On the right hand side, distribute that 160 to the X and the 30. So we get 60 plus X equals 160X. We only want one X on one side, so subtract that X. Now keep in mind the coefficient of X is 1, or 1.00. So we're going to subtract 1.00 X from 160 and get 0.60X. Now we're going to get that variable by itself. So get rid of the constant, 48, and then get rid of the coefficient, divide both sides by 0.60, and that's going to give us 20 ounces of herbs at $1. Alright, so now we're going to look at percent mixture. So what the formula we're going to look at is AR equals Q. A is the amount of material we're working with. R is what percent of that amount is some type of item of interest. And Q is how much pure material of interest is in that amount of material that we're looking at. So kind of see what we're talking about here. Let's say I had a 5 kilogram piece of metal and I knew 30% of it was iron. And I want to know how much of this thing is iron. And so I'm going to go to my formula and I'm going to say, well, I know I have 5 kilograms. I know 30% of it's iron. So I'm going to multiply 5 times 30%, and that's going to give me 1.5 kilograms of iron is in there. And then the other 3.5 kilograms is some other type of metal. This is just the percent formula, exactly like we've seen before. The base is how much of stuff do you have. The value is the quantity of this pure material you're looking at. And so again, looking at mixture, you're going to be adding how much pure material you have in the first one plus how much pure material you have in the second one. And that's going to give you your total amount of pure material. Back that up a little bit. So how do we find the pure amount? We take the total amount of stuff we have times its percent that's pure, amount of the second one times its percent that's pure, and that's going to equal the total amount and its percent that's pure. And again, this total pure amount percent is going to be this total percent that's pure is going to be somewhere in between the two individual values. A note, sometimes we're going to mix pure material with something that is not pure. And so if this material you're mixing is of the thing you care about. Now what do I mean by that? It's the thing that all the rates or all the percentages are based on. Then we're going to say it's 100%, because if it's pure, silver or gold or iron or whatever, acid, then it's 100% that. If, on the other hand, the substance we're looking at is pure something, but it's not what all the other rates are related to. So if you have a shampoo that's 20% conditioner and you mix that up with a shampoo that's just pure shampoo, no conditioner, the rate would be 0% conditioner, because you're talking about percentages based on conditioner. So that's how that's going to... You have to be careful when you're dealing with a pure substance. Is it what the other interests are related to, or is it not? And if it is, it's 100%. If it's not, it's 0%. And we'll look at a couple examples to see what we're talking about there. But let's look at a kind of a more standard type example. How many pounds of chicken feed that is 50% corn must be mixed with 400 pounds of feed that is 80% corn to make a chicken feed that is 75% corn. And again, notice that 75 is between the 50 and the 80. So X is how many pounds of 50% corn we're looking for. So we go to our formula. We're looking for the pure thing we're looking at here is corn. So how much corn in the first one plus how much corn in the second one is how much corn overall. So we take how many pounds of the first one times its rate plus how many pounds of the second one times its rate, and that'll give us some total amount here. How many pounds are we looking at? Well, we know we have 400 pounds of the second type, and we have X number of pounds of the first type, so the total must be X plus 400 pounds. So filling in all the stuff we know, some number of pounds of the first one times 50%, 400 pounds of the second one times 80%, that's going to equal this X plus 400 total pounds, and we want this to come out to be 75% corn. So again, distribute on that right hand side, multiply the other things together, and we get 0.50x plus 320 equals 0.75x plus 300. Make sure you only have x's on one side, so I'm going to subtract the 0.50x from both sides. And now I'm going to isolate that x, get rid of the coefficient, or get rid of the constant, subtract 300 from both sides, then get rid of the coefficient, divide both sides by 0.25, and we're going to find out we need 80 pounds of the 50% corn mixture. Now, does that make sense? Well, if you think about it, we had 400 pounds of the 80%, and the overall mixture is going to be 75% corn. Well, that's very close to 80, which means we have a lot more of the 80% than we have the 50%. So yeah, 80%, 80 pounds of the 50, yeah, compared to 400 pounds of the 80, that does make sense. All right, so let's talk about some pure stuff. So let's say I have 30 ounces of pure silver added to 50 ounces of a silver alloy that is 20% silver. What is the percent concentration of the resulting mixture? So I want to know what's the percent of silver in the final alloy. Ag is chemical name for silver. So I go to my quantities, pure silver plus pure silver equals pure silver. How do I figure out how much pure silver I have in the first one? I take the amount I have times its percent pure silver times the amount of the second one times its percent silver, and the total times its percent silver. How many total pounds or total ounces of silver do I have? I have 80. I have 30 of the first one and 50 of the second one, so I have 80. Notice I'm talking about 20% silver for the second one. That means my percentages are based on silver, and I'm adding pure silver. So pure silver is 100% silver. That's why the first percentage is 100%. Multiply the left-hand side, add them together, and then get x by itself, divide both sides by 80, the coefficient, and you get x equals 0.5 or 50% silver in the final alloy. And again, that's between 20% and 100%, so it does make sense. Alright, so now let's look at one last problem. How many grams of pure water must be added to 50% of pure acid to make a solution that is 40% acid? Now look at that last bit. I'm looking for something that's 40% acid. My percentages are based on acid, not water. They're based on acid. So I'm looking for how many grams of pure water, H2O is water. Again, now remember, we're talking about percent acid. So how much acid's in the first one plus how much acid's in the second one is going to be giving me my total amount of acid. How do I figure out how much acid? I take how many grams I have times what portion it's acid. How many grams do I have? What portion is acid? That's going to give me a total number of grams. What portion overall is acid? So I'm going to start filling in what I know. Well, I don't know how much water I have, but I know what percent water is that is acid, and that is 0. And I know that I have 50 grams that is pure acid, so it's 100%. And so how many total grams am I working with? Well, again, x plus 50 grams. You know, even though that water isn't giving me any acid, it's still an amount in the mixture, in the solution. And I wanted that to come out to be 40%. So distribute that 0.40 on the right-hand side. 0 times x is 0. So that's gone. So 50 equals 0.40x plus 20. Get rid of the, so we only have one x right now. Get rid of the constant, subtract 20. And then get rid of the coefficient, so divide both sides by 0.40. And that gives us 75 grams of pure H2O, pure water. So even though the water didn't contribute any acid to our mixture, it did contribute amount to our mixture. And so that's what diluted the acid to a 40% acid mixture from a 100% acid mixture.